What's going on, guys? In this video we are going to see an example on hypothesis test. Let's look at this example right here. Here this question is asking the mean amount of fluid in a bottle of lens cleaner is 59 milliliter. A researcher believes that the mean is actually lower than that. 15 bottles are sampled and the mean is found to be 58 milliliter with a standard deviation of 1.2 milliliter. Test the claim based on this information at alpha is equal to 0.05. Assume it is normally distributed and so on, right? So here they are asking to test the claim. Okay, now here we are going to use the classical approach. Now in order to do classical approach, you have to follow these steps. Now let's go ahead and put the information first. First they are saying the mean amount of the fluid in the bottle is 59 milliliter. So we know that mu is equal to 59 milliliter, right? And after that, a researcher believes that the mean is actually lower than that. Okay, so the claim here is a researcher believes that this is lower than 59. Okay, then we have 15 bottles are sampled. N is equal to 15. And 15 bottles are sampled and the mean is found to be 58 milliliter. So we have the X bar, that is 58 milliliter, and the standard deviation of 1.2 milliliter. So we have the S value, that is 1.2 milliliter, and also they have given the alpha value, that is 0.05. Now let's look at the steps. So the first step is write down a shortened version of claim. So we have written that right here. And then after that, come up with null and alternate hypothesis. H0 always has the equal part on it, and see if claim matches H0 or H1. Now here, in order to do this one, we have to know some stuffs like this. Like H0 always has less than or equal to, greater than or equal to, or equal to. So these are the only possible signs for the null hypothesis. For alternate hypothesis, we have these three signs: less than, greater than, and not equal to. And if you look at this one, this falls under this sign, right? Lower than 59. So this is definitely alternate hypothesis. So we can go ahead and write. So let's put H0, H1. And this one falls under H1 because it's this sign only possible for H1. And since we are talking about the mean, right? Mean, we put mu right here, and mu is less than 59. Okay, so here if the alternate is less than 59, null is opposite. These two are opposite to each other, so we get mu is greater than or equal to 59. So now we have got this one. Now let's go to the next step. Draw the picture and split alpha into tails. So here says if the mu is not equal to the value we get, that is 2 tails, and mu is less than value, left tail, mu is greater than value, right tail. In this condition, here we have, in the alternate hypothesis, mu is less than the value, right? That's what we have right here. Okay, so this is going to be in left tail. This alpha value is going to be in left tail. So if we draw a diagram like this, and if we split like this is our alpha value is 0.05. okay, so 0.05 is going to be in the left tail. This is our left tail, so if this is 0.05, this is going to be 0.95. okay, now this one falls under that, and after that find critical values using t distribution table. So we are going to use this table right here, t distribution table. But before we do that, we have to know one more thing. We have to find the degree freedom. To find degree freedom, we use this equation. Degree freedom is equal to n minus 1. N is the number of samples, that is 15, minus 1, and that's going to give us 14. And 14 degree freedom, and the alpha is all we need to find out the t distribution value, the critical value. Now it's 14 and 0.05. and if you look at the value that matches these two, that is 1.761, and since we have this alpha in the left side, this is going to be negative. So this critical value right here is going to be negative 1.761. Okay, so now we have found out our critical value. The next step is find the test statistics t-test. So we have to find the t-test value. Now let's go ahead and find that one. Okay, here we go. Okay, first select stats and go to tests. Okay, I make this one bigger. Go to test, so we put this arrow right here and go to t-test and then enter, and here we have this set of data, and we know that mu value is 59, right? So from our information we know that mu value is 59. So let's enter that one right here, and before that make sure you select the stats. Okay, and go down 59, and after that x bar is equal to 58. X bar is 58, and then standard deviation is 1.2. So this is 1.2, and after that n is 15, number of samples, that's 15, and we know that this is lesser than, so go down, lesser than, enter, and that's it. Now let's go ahead and calculate this one, and here we are getting t value is negative 3.227. So let's write that one down right here, negative 3.227. So we found out, let's note that one right here, t-test. Okay, here we found out t is equal to negative 3.23. Okay, 3.23. If we round this one, 3.23. And if you look at this one, if this is negative 1.761, this negative 3.23 definitely goes in this side, right? Because it's lesser than this one, right? So this falls under the tail, right? It falls under this area. Okay, so here it says if the test statistics fall in tail, reject h0. So this is falling in tail, right? We are getting this value lesser than this, so this is falling in tail. So here we are going to reject the null hypothesis. So we reject h0. So let's go ahead and write our final conclusion. We reject h0. So if we reject h0, we accept this h1. Accept h1, and if we accept h1, this is going to be, the climb is h1, right? We found out that this is lesser than 59, and that was h1. So the climb, so we are going to accept the climb. So that's going to be the final conclusion. Accept the climb. And that's how we do this kind of problems. I hope this helps. Thanks for watching.